question now is, in which direction is this object going to start to accelerate? Which direction are these forces going to cause this object to move? Because forces cause objects to accelerate in the direction of the net external force. So what we need to do is we need to figure out what the net force is. Sometimes we write it as the sum of the forces, and it's a vector term, or sometimes we write it as F subscript net to indicate the net force acting on the object. Now in this case, there are three forces acting on this object. There's force 1, force 2, and force 3. So what we're going to do is we're going to add up all three of those forces. And remember, they're vector terms indicating that they have both magnitude and direction. So F1 plus force 2 plus force 3. Now in this case, what we're going to do is we're going to add force 1. Force 1 has a magnitude of 50 newtons and it's being pulled in the positive x direction. And then we're going to add to that force F2, which has a magnitude of 30 newtons. And to that, we're going to add force F3, which has a magnitude of 40 newtons, but it's being pulled in the negative x direction. So I'm going to indicate that by writing negative 40, indicating it's being pulled in the negative x direction. And I should have, for clarity, put a negative sign in here to indicate that it's being pulled in the negative x direction. So the magnitude of the force is 40 newtons. And the direction in which it's being pulled is in the negative x direction. Now the next step is to add up all the forces. In this case, 50 newtons plus 30 newtons works out to be 80 newtons. And then you're going to add negative 40 newtons. And this works out to be 80 newtons plus a negative 40 newtons, which works out to be 80 minus 40, or a total force, a net force of 40 newtons. So if we look back up at our object, there's going to be a net force acting on this direction, causing this object to accelerate off in this direction. And the magnitude of that force is going to be a force of 40 newtons, and it's going to be pushing or pulling this object in the positive x direction. Remember, forces are applied to objects in two ways, either by pushing on them or pulling on them. Now, if we suppose that this object has a mass of 4 kilograms, we can figure out how fast this object is going to accelerate. So let's take a look at that. So if we look at Newton's second law, which says that if you add up all the forces acting on an object, it's going to equal the mass of the object times the acceleration of the object. Now in this case, we've figured out the net force. We've figured out the total force causing this object to accelerate in the positive x direction. We know the mass of this object. So now all we have to do is solve for the acceleration to figure out how fast this object is speeding up. So in this case, what I'm going to do is I'm going to divide both sides of this equation by the mass term. What you do to one side of an equation, you do to the other side. And then what you'll see is this term here cancels out with this term here. And we now have an expression for the acceleration of this object as the sum of the forces divided by the mass of the object. Now in this case, the net force acting on this object in the positive x direction was a force of 40 newtons. And we're going to divide that by the mass, which we said was 4 kilograms. Now when you divide 40 by 4, you get the number 10. So 40 divided by 4 is 10. And then when you divide a newton divided by a kilogram, you get a unit of a meter per second squared. So this object's acceleration, when a net force of 40 newtons is applied to it, is going to be 10 meters per second per second. And if we look back up here, this object's going to accelerate in this direction. And in this case, it's going to be a magnitude of 10 meters per second squared, off in the x direction, the positive x direction. And again, notice that the net force and the acceleration are in the same direction. That's exactly what Newton's second law says.
Where did it say that it's 4 kilograms?
Oh, you just use that as an example.
Oh, okay. So a car has a mass of 1,000 kilograms plus the acceleration is a force of 2,000 meters.
Is it 2 meters per second?
Per second.
Per second, right?
Car has an acceleration of 5 meters per second squared and a mass of 20 kilograms plus Okay, ignore this one. The tension in the strings. Like
C and an A equals B.
let me have like question about this one.
Wait, how do you find the tension?
The tension is like
What tension is
this and that.
So basically, I believe it's, you see, there's a hanging mass. 1 kilogram equals 10 newtons. So I believe what you do is, you would, you basically convert 1 kilogram into Newton. So 1 kg equals 10 newtons. So that's 1 kg now automatically equals 10 newtons. And because B and C is 3 kg, 3 times 10 is 30.
So the tension basically is the like the net force.
Yeah.
Force.
Of both of the weights?
No,
Or
just the
Just-
hanging mass.
Wait,
So
so
if
then
it
why
was-
doesn't B equal C? Then why does it have
Yeah,
force equals
why does
mass?
C is A equals zero?
I remember doing like
No, like the order is not A, B, and C. The calculate order is not A,
Can.
B, C. So the tension equals like mass equals mass times acceleration. So the first one is mass is 10 newtons, and the acceleration is we got from the first question is 2.5 meters per second squared. So this one is
find the acceleration of the entire system and multiply by
and for the B is
You multiply it by the mass of just one block.
30 newtons,
The upper block.
is 7.1 meters per second squared.
Do you have to convert to newtons or can you just keep it?
I'm gonna,
They multiply by the bottom.
hold on.
Yeah.
Should I say
And for the
You
third
can,
one is
if you have opinions, you can chime in when she's done.
mass times acceleration is 30 newtons times acceleration. The third one is 5 meters per second squared. It's like
So for the first one, for A, so you would only use the weight of the, so you would convert the mass into newtons for just the hanging mass, right?
yeah,
Not
because
the
this is
whole
the
thing.
force. This is the physical force. The hanging is the body force.
Okay, so it's not both of the weights combined? No. Okay.
It's like the cart, thing that we did.
Yeah, okay.
You know in part A how it's like 30N, 30N, and 10N? You get that from the top, like from changing it to units in the top boxes or bottom boxes there?
The hanging mass.
Okay.
Okay, so a rope sits on a frictionless surface which is connected to the post and the rope to a second block which is hanging. When the system is released, the block starts sliding. What is the acceleration of this part of the system?
Is it 4.4?
Can you give us the
Well, I did 40 newtons over 9. Did you do that? Yeah.
and what's the force of tension in the rope?
Yeah.
Because it's because tension equals to the force, and force equal to the mass times acceleration. So we got now the acceleration just times the mass.
No, but I thought it was the mass of the hanging object.
This one?
Yeah, no, like for the tension, aren't you supposed to do the mass of the hanging object for the tension? Like instead of 5, do 4.
No, but this is the mass of the object, and it includes all the tension. Yeah.
But I thought it was supposed to be the hanging mass, like in the problem before you did the hanging mass.
Wait, what's
So I think go back. Can you go back one slide? Because I think they have picked up on something. So on this sheet, it looks like you used the hanging block to find the tension, and on the next sheet, you used the block sitting on the table.
See, it says 1.
No,
But no, that
in
it's going in
this
the
one.
order of
Yeah,
BCA.
the order of that is like this one. We find the acceleration of this both third system, and if you want to find tension,
Oh, so
we
it's
just use
wrong.
acceleration
No,
two times.
use
Okay, so acceleration with the upper block is what you're saying here. Okay.
Wait, but which one? Like how do you? Yeah, which one?
So they're right in both cases. They use the upper block with the acceleration of the system to find the tension in the rope. And that's what they're doing here also. The other one's confusing, I think, because the things are just out of order. They're not ABC. So click one more time so that click ahead one more time so the tension calculation comes up.
So we just find the acceleration of the system, and if we want to find the tension, we just use the acceleration we got in times the block here.
But why do you why is the block there? What it I don't
It's the
understand.
mass.
Of the object.
Would the mass of but wouldn't be 5
No, this is the, okay,
They
so.
did 5 plus 4 is 9, so they did 41 is divided by 9 kilograms.
But why is tension only the upper block? Yeah,
No,
I thought it was the bottom one pulling it down.
Because it's science, they need an explanation.
So